Do you know that Mikrotik has up to 6 different ways for configuring VLANs on their different devices? On this video, I'm gonna show you how to configure correctly and efficiently VLANs on the Cloud Router Switches or CRS300 series. And specifically, I'm gonna use a CRS326 device. Let's get started and go to the lab. Before starting with the configuration process, I will show you exactly what are we going to do. Mikrotik has two operating systems for layer 2 devices, Router OS and Switch OS. If we go with Router OS, then we have devices that are including switch chips, and we have devices that don't have any switch chip at all. If we take devices with switch chip, then we have two main categories, router boards and CRS. CRS are the cloud router switches, and there we have three big families, 100, 200, and 300. Each of those families, as you can see here, have a different way for configuring VLANs. In this video, I'm going to show you how to configure VLANs on a device from the family 300. I'm going to include one video per family, so at the end you will know how to configure efficiently and correctly VLANs on any Mikrotik device. The process that we can take in a 300 device is the following. It's a 5-step process. So I will go through each of those steps in my topology. So before starting with this process, I will show you the topology that I have here. So you can see that I have a router and then I have two switches. I have one switch over here and I have the second one on the right. So those will be CRS326. In this case, I'm using GNS3 to virtualize those devices. But in a real production environment, those must be 300 switches. But the process that I'm going to show you is exactly the same process that I will take in a physical device. If you don't have GNS3 or you don't know how to try this functionality, you can check that video and then you will learn how to install GNS3 and how to include Mikrotik images, and you can play with this. So in this scenario, we have three VLANs. As you can see there, you have VLAN 10 that is intended for the marketing department. We have VLAN 20 for IT, and we have one management VLAN, VLAN 99. So here we have all the subnets that are assigned to each VLAN. This here will be a trunk link. Basically, all the inter-VLAN routing process will be managed on the router, and then that trunk link will be sending the traffic to this switch below, CRS326-1. Then in that switch, we have two different types of ports, trunk and access. Trunk ports are the ones that are going to be sending traffic for one or more VLANs. An access port is a port that is mapped to a specific VLAN, and all the frames that are sent out are not going to include any VLAN tag at all. So that means that these PCs here doesn't need to have any VLAN configuration. They are just going to be connected to the switch, and they automatically will be mapped to the VLAN 10 in this particular case. Additionally, we have some devices assigned to the VLAN 20. That means that we are going to have two VLANs, two different broadcast domains at that point. The management VLAN will be used just for management purposes on those two switches. So to start, I will configure the router. So this will be a router on a stick. So we don't have any special configuration there. So I will go to the Winbox, and you can see that I have here the CSR. So I will get connected to it. For the router, my first step will be to add all the sub-interfaces required for each VLAN. So if I go to this device to interfaces, ether 1 is the interface connected to a CRS. So I will add a comment and I will say link to CRS326-1. Now I need to add three VLAN interfaces. I need to go here to interfaces, and then I have here the tab VLAN. So I will go to VLAN. I can add a new VLAN, and I will call that one VLAN-10. Then I will assign the VLAN ID. In this case, that will be 10, and the main or master interface in this case will be ether 1. So this interface here is the one that is connected to the CRS. So remember that. Then I can click in OK. Now I have one VLAN interface. So I need to add two more. So now I will have VLAN 20, VLAN ID 20, same ether 1, OK again. And now I have the VLAN 99. This will be the management VLAN. So VLAN ID 99 and then OK. So I have three VLAN interfaces on my router. Now I need to assign one IP address to each sub-interface. The IP address that I'm going to assign to each VLAN interface will come from the subnet that is associated to that particular VLAN. So in this case, you can see here VLAN 10, I'm using that subnet, VLAN 20, and so on and so forth. So the IP will be the first usable IP, in this case .1. So to add an address on Mikrotik, I need to go to IP and then addresses. I'll click the add button and then I can assign the first IP, 172.16.10.1/24, and that will be mapped to the VLAN 10. Then OK, and I will assign the second IP to the second VLAN interface, 172.16.21/24, in this case VLAN 20, then OK, and finally the management VLAN 10.99.99.1/24, that will be mapped to VLAN 99, and then OK. Now I need to configure that CRS326. Since I'm using the cloud object here and I connect it to the router, I will use Roman to get access to that device. That's a protocol that Mikrotik has available for us when we need to have access to a device that is in a different broadcast domain. So in this case, I'm going to Tools and then Roman, and I will enable that feature. And now I will go to the console on that CRS, web console, and I will type the following command: tool Roman set enable equal yes. And also I will change the system identity or host name, system identity set name CRS326-1 and enter. So that means that in this moment I will be able to get access to that CRS via Winbox. So I need a new window for the Winbox. So you can see here I have my main router. I will connect to Roman, and you will see here that I'm going to get the CRS326-1. So I will click on that, and now I can click on connect. And I have access to that CRS. So I am in the switch now. So I need to follow this process. So my first step is to create a bridge interface. Please remember that a CRS has one switch chip. So we only need to have one bridge interface. Please don't add multiple bridge interfaces because that's inefficient. So I will create one bridge interface and then I will add all the ports on it. So I'm going to bridge and then I will add a bridge. So I will call that one bridge. Okay. So that's my first step. Now it's completed. I'm going to the second step, add ports to the bridge. In this step, I will add all the used ports to the bridge. So that's very simple. So I'm going to the bridge again, and now I need to go to the ports tab. And here I need to add all the interfaces that are connected. So you can see that I have Ether 1, 2, 3, 4, 5, and 6. So all of those interfaces will be added to that bridge. So I'm going here, add ports. You can see Ether 1 to the bridge. Then I will do the same with Ether 2, Ether 3, Ether 4, Ether 5, and then Ether 6. So now I have all the used interfaces added to the bridge. One good practice is to disable all unused interfaces. So in this case, I'm going to interfaces, and since I'm not using Ether 7 to 10, I will select all of them and I will press this disable button. So this is a good practice. So now I have completed the step 2. Remember, step 1 was creating the bridge. The step 2 is adding all the ports that I am using in this topology. The step number 3 is to create the VLAN table. And there we need to identify the tag and the on-tag ports. From here, you can say that the tag ports will be the trunk ports and the on-tag ports will be the access ports. The step 3 is probably the most important step to successfully configure VLANs in a CRS300 device. So I'm going back to my topology, and I need to identify all the trunk interfaces and I need to identify all the access interfaces. If we see this topology, our conclusion will be that this link here and that link there are trunk links. And also, we know that all of those interfaces there are access ports because we only have a single device connected to them. So once we have identified all the trunk and access ports, then we can go to create the VLAN table. So to create the VLAN table, I need to go to bridge, and then you can see here this tab. On VLANs, I will click on the plus button. I need one entry per VLAN. So in this case, I will start with VLAN 10. VLAN 10 is the marketing's VLAN. After adding that VLAN ID, then I need to identify the trunk and access ports for that particular VLAN. VLAN 10 will be transmitted in that link and also will be transmitted in those two links, Ether 2 and Ether 3. VLAN 10 has nothing to do with Ether 4 and 5. So that means that for my tag interface, I will select Ether 1. That means that every frame that is going out Ether 1 will have the VLAN headed included for that particular VLAN. Then for the on tag, those are the access ports. So here we have Ether 2, and also I will add a second port, in this case Ether 3. And now I can click on apply and then OK. So I must repeat the same process for VLAN 20. So I will click on add. Now the VLAN ID will be 20. And if we see for VLAN 20, this will be the trunk interface, and those two here will be the on-tag interfaces. So my tag interface will be again Ether 1, and my on-tag interfaces will be Ether 4 and also Ether 5. And now I can click OK. So I have two VLANs, but I'm missing my management VLAN, so I need the management VLAN here as well. So I will click on the plus button, and now I will add the VLAN ID 99. In this particular case for VLAN 99, I only need the trunk interface. So my tag interface will be Ether 1, the interface that is facing the router. But additionally, since this is the management VLAN, I need to add access to the CPU. This is the way how Mikrotik handles that. Basically, that means that I need to add as a tag interface the bridge itself. And this is going to allow access to the CPU to the VLAN 99. So this is the way how Mikrotik handles the management access to the CPU. So I will click on apply and now OK. At this point, we have completed our VLAN table. Now we need to add the port VLAN ID to each access port. To do that, we need to go to the ports tab, and then one by one, we need to specify the appropriate value for the port's VLAN ID. So I'm starting with Ether 2. So I will go to Ether 2, and you can see this tab VLAN. So I will change the PVID to 10. So this port is mapped to VLAN 10 and Ether 3 as well. So I'm going to click OK, then I'm going to Ether 3, this is 10, Ether 4 will be 20, Ether 5 will be 20. And now we have all the access ports with the correct value for the port VLAN ID. So the next step is to add the management VLAN. So this is basically a VLAN interface where we need to specify the IP address that we are going to use to manage that bridge. So I'm going to the CRS, and now I need to go to interfaces and then to VLAN, and I will add a VLAN interface. So I will call that one VLAN 99, and the VLAN ID will be 99. One important point here is that the master interface in this case will be the bridge. Now we can click OK, and we can assign an IP address to that VLAN. So IP address plus button, and now you can see here I will use the .2 IP address that will come from the management subnet. So the IP will be 10.99.99.2/24. Interface will be the VLAN 99 interface. Now I can click on apply. OK. If we are going to be managing this device from remote networks, then we need to add a route, a default route. So I will go to IP, then route, and I will click the plus button, and gateway will be 10.99.99.1. So the default gateway will be the IP that is configured on the interface VLAN 99 on the router. So we need to apply security policies, then we can add those into the router's firewall. So I will click OK. Now if I go to the terminal, I must be able to ping the default gateway on the router. You can see that I successfully have gotten the echo reply messages coming from the router. So I'm almost done with this configuration. So my final step is to activate VLAN filtering. So I'm going to the CRS, to bridge, and then to the bridge tab. I will open this bridge entry that is here. And now if we go to the VLAN tab, we can click on VLAN filtering. After that, we can click OK. And now the VLAN filtering has been applied successfully, and all the configuration that we have performed must be working properly. How can we test that? Basically, what I'm going to do is that I'm going to add a DHCP server in that router, and then if we try to get an IP address from those devices must get an IP coming from the appropriate VLAN. So let's try that. So I'm going to the router. So this is the router, IP, DHCP server, DHCP setup. I will select the VLAN 10, next. So I will use all the default configuration for that device, and everything must work correctly. So I will do the same process for VLAN 20, next, and finally we have two DHCP servers running on the router. So I will go to this PC1, right click, web console, and I'm going to say IP DHCP. This must get an IP coming from the VLAN number 10. The DORA process has been completed successfully, and it has an IP coming from VLAN 10. If I try to ping my default gateway 10.1, that is working properly. So that means that this access port where PC1 is connected is working properly. Now we can do the same with one device connected to VLAN 20. So web console, IP, DHCP, enter, and this must get an IP coming from VLAN 20. Let's see if that's true. And that's it. So we have gotten an IP from VLAN 20. I will try to ping 172.16.21, and we can reach our default gateway. I will try to ping one IP on VLAN 10, like 10.1. You can see that we can successfully ping that device. So the router is performing the inter-VLAN routing. This switch has all the access ports and trunk ports working properly. What happens if we have a second switch in our topology, and then we need to expand the scope for one particular VLAN, like in this case? You can see here that we have a second switch, probably that can be in a remote building, in a different office. In this case, we only have users connected to the VLAN 10. in that remote location. So we can identify here a new trunk link, the one that is connecting the switch 1 to the switch 2. That trunk link in this case will be sending traffic only for VLAN 10 and VLAN 99. We don't have any device for VLAN 20 in the remote location, so we don't need to send that VLAN out that trunk link. So in this case, we need to make some modification on the first switch, since we need to configure Ether6 as a trunk interface. After that, we need to get into the second switch, and then we can configure those two interfaces, the trunk interface and then the access interface. So I'm going back to the switch number 1, and I need to modify my VLAN table, since now I need to add the Ether6 to VLAN 10 and VLAN 99. So I will modify the entry for VLAN 10. So I will double click on that entry. So I'm going here and I will add a new entry, and I will select Ether6, and then I will click OK. I will do the same for VLAN 99. So I'm opening the entry for VLAN 99. I need to add a new tag interface, and that will be Ether6. Now we can click OK. So that means that at this point, this device here knows that all the traffic for VLAN 10 and VLAN 99 going out of Ether6 must include a header for that VLAN ID. We are ready with the switch number 1. Now we can go with the second switch. So I will go to that device. I am here on that switch. So my first step is to add a bridge interface. So I have that there. Then I need to add all the ports that I'm using. So in this case, I'm only using Ether 1 and 2. So I will add those two entries, Ether 1 to the bridge and then Ether 2. I have those two interfaces, and I will disable all the remaining interfaces. This is a good practice. This is not mandatory, but it's a good idea to do that. So I will keep enable only the interfaces that I'm using in this particular moment. Then my next step is to create the VLAN table. So I will go to VLANs, and here I only need two VLANs, VLAN 10 and VLAN 99. So I'm starting with VLAN 10. So the VLAN ID 10, my tag interface will be Ether 1, and my on-tag interface is the one where the endpoint is connected, in this case Ether 2. And then I will click OK. Then I have the management VLAN, so that's VLAN 99. My tag interface is the same that is connected to the uplink switch. So in this case, that's Ether 1. In this case, we don't have access ports because this is a management VLAN, but that VLAN needs access to the CPU. And to do that, we need to add to the tag section the bridge interface. So I'm adding that one. We'll click apply, OK. And I have those two entries in my VLAN table. My next step is to set the port VLAN ID for every access port. In this case, I only have one access port, and that's Ether 2. So I will go to ports, Ether 2, and I will set the value for the port VLAN ID to VLAN 10. You can see here that port is mapped to VLAN 10. So I'm adding the VLAN 10, OK. My second last step is to add the management interface, because I need to assign an IP address to this device. So I will go to interfaces, then VLAN, and I will add a new entry here. I will call that one VLAN 99. The VLAN ID will be 99, and the interface will be the bridge. Now I can click OK. As you can see here, the IP that I'm going to use for management in that switch will be .3. Still, I'm going to use the same subnet for the management VLAN. So I will go to IP addresses. I will add a new value here, 10.99.99.3/24, and that will be assigned to VLAN 99. I can click OK. And now I need a default route if I need to get access from a different network to that device. I'll add a new one, and then the gateway will be the IP configured on the router, 10.99.99.1. I can try to ping that router, ping 10.99.99.1, and you can see that we have successfully reached our router. So I will expand this just to see the full response here, and you can see that I'm getting response from my router. So we don't have enabled all the configurations that we have just added to this device. So to do that, I need to go to bridge and then to the bridge interface, VLAN, and I will enable VLAN filtering. Now I can click OK. And if I go back to VLANs, then you can see that now I have the current tag and current on tag fields showing information about the appropriate ports. So that means that at this point, if I go to my topology and I try to get an IP via DHCP on this virtual PC, I must get one from VLAN 10. IP, DHCP, enter, and you will see the DORA process successfully completed. And that means that I have an IP from the VLAN 10. I can try to ping my gateway, and you can see that I can successfully ping that device. If I try to ping another device from a different network, like this one here, show IP, you can see that is 2254. And we'll go back to PC5, the one on the remote location. Ping is 172.16.2254, and you can see that I can successfully ping that device. Additionally, at this moment, we don't have any security policy in the router. That means that any user can have IP connectivity to any switch. So you can see I can reach the switch number 2 from a user's PC. So what is happening here, all this traffic is going to the router, then the router is routing that traffic to the appropriate IP. So that's something that we must avoid. So we can include some policy rules in the router. How can we block the access to those management IP for traffic coming from those VLANs? So we can just add a simple rule here. I will go to the router. So this is the router, and Mikrotik has something that is called address list. So I can go to IP, then firewall, then address list. I can add an address list and include all the networks that are assigned for users. Like for example, user network, and I can add an entry for each of those, like 172.16.10.0/24. I can apply that. I will copy for the second subnet. You can see that I have now one address list with 2 entries, one per VLAN. That means that now I can use that address list and block all the traffic that is coming from any of those networks to the management VLAN. So to do that, I can go to filter, and then I can add a new entry here, and I can say forward. So in this case, it will be the forward chain. This is traffic that is going through the router. And then I can go to advanced source address list, and I can select user network. I can go back to general, and then here in destination address, I can say 10.99.99.0/24. So this is basically telling to router A that if any packet coming from a user's network is trying to reach an IP in the management VLAN, then we can drop that packet. So I will say block user traffic to management VLAN. I can click OK, and basically now if I go back to this PC and I try to ping the management VLAN again, you can see that that user won't be able to reach any management IP. So that had been applied to the forward traffic. So in Mikrotik, there are 3 chains: input, forward, and output. Forward is traffic that is going through the router. If there is traffic that is going to the router, that is called input. So that means that since the rule has been applied to the forward only, if I try to ping the IP that is configured on the router, that is going to reply. So if I need to block the access to that IP as well, then I need to add the same rule. I will copy that one, but I will include the chain input. So now if I repeat the ping, you can see that that user is not able to reach any management IP address. This is the appropriate method that you must follow when configuring a CRS300 device. This is going to take advantage of the switch chip. Everything will be handled in a hardware level. Thank you for watching, and I see you in the next one.